Transformations. Okay, this is called the circle of transformations. Just to make it a funny sound so it gets stuck in your head. Now, let's just have a look at this top right quadrant. Imagine you've got this blue data, and it's actually like this curve represents, you've got all these dotty lines like this, and you can quite clearly see that a curve fits it better than the green straight line. So you've got to do a transformation. You've got to change those blue dots somehow and make them more like the green line. So you have a few options. So the first one you can think about is like you want to push all the values out this way a bit more. And so you can do that by squaring x, because that's the x direction. And so you're stretching them out in the x direction. You could also do the same thing and actually stretch them up in the y direction like that. And so y squared would also be an acceptable transformation. If we go to the next quadrant down here, so if you have all our data that looks like that, that's a smiley face versus the straight green line, then you could do the same thing. You can go, well, I'll stretch in the x like that, so I can do x squared again. But now in the y direction, I want it to shrink them down in the y direction to hit the line. So there's two ways to shrink. You can go log of y, or you can go inverse y. Now inverse y can also be called 1 over y because it looks like 1 over y, or you can call it reciprocal y. So inverse 1 over y or reciprocal y, all the same thing. And so by sort of symmetry, you can see how this all works out. So you still want to do the same thing down this way. So you still want log of y for this quadrant and inverse y. If you want to shrink x, then you need to do log of x. Log. Remember when you write log, it's log 10 by default. So you don't have to write log 10 or use your fancy button on your calculator for that. You can do that anyway. Just log 1 over x. By symmetry, of course, this looks like the same, so that you want to shrink x, or you can stretch y. So if you get data that looks like this curve, then you can do this transform or this transform, two choices. If you get data that looks like this one, then you can do 1, 2, 3, 4 transforms. So you just got to see how you're going with your data, what kind of curve you have, whether it's this blue curve, to make it into a green straight line so that you can actually do linear algebra on it. So you should make sure you have a copy of the circle of transformations somewhere in your notes. It's too big for me to keep pulling up and trying to squish into the screen, but you should get one from your book or something. Stick that in your notes. Very, very useful. Here's some genuine data about fertility rates and money. So how many births per female versus how much money earns per person in US dollars. So the first thing you do, you stick all that in your calculator. Now it's good habit to make a little note of what you're doing. So list 1 is our X, and that was the fertility rate. And list 2 is our Y, and that is GDP. And just keep a track of all those things on the and much easier than trying to rename all your lists, unless you're one of those show-off people who knows how to do all the functions on their calculator. All right, calc, regression, linear reg as normal. Now, don't forget, we're going to put the residual into list 3. Oh, got to keep track of that. List 3 equals residual. And so what we're saying here is like, so for no transform, because we haven't done any transforms yet, we've got an R that equals minus 0.694. Okay. And so if we're going to transform the data, remember we're trying to shift the dots closer to the line, so the R should get stronger. All right, and so if we do a good transform, the R should get stronger. All right, so if we look at this graph, quite clearly we're getting a smiley face, which we don't want. We want to just flatten that curve. So we want to bring down the Y's. So if you want to bring down the Y's, you could log of Y or inverse Y. And you might also want to sort of shrink in the X direction. So you could do log of x or reciprocal x as well. So any of those four transforms should work. All right, so let's have a go at, first of all, let's just we'll delete all this mess. And then we're going to just do a quick scatter plot of the residual. And again, annoyingly, it does keep this line in here, which was the previous regression line, which we know is actually now this line along here. But clearly you can see that smiley face, which we don't want. All right, so our first transform, if you look here, we've got, we click on the bottom of list 4, this cal thing appears, and then you'd say log of list 2. So list 4 equals log of list 2, which we know from our list here is y. So that's log of y. That's a g there. All right. So when you do all that, magically, it does all the calculations for you here. And then you've got to do calc regression linear reg, but this time list 1 versus list 4. And so if you do that, you get these values here. So we're going to say with the log of y transform, we're going to say r equals minus 0.826. Well, that worked really, really well. We've got a massive improvement in the r, therefore we can say that the log y transform is a good transform. So we're just going to do a quick scatter plot of that, list 1 versus list 4. And if you see that, the dots do look closer to the line than they did before. We have a less obvious smiley face. All right. Let's do another transform. So we're doing list 5 this time. So we click on the bottom of list 5, the cal appears, and we're going to do that. Now, so we said we could also do list 5 equals 1 over x. So for the 1 over x, or the reciprocal x, or the inverse x, whichever takes your fancy, r equals, well, we've got to work out what that r is. So that's going to be list 5 versus list 2. And if we do that, we get an r that is negative, sorry, not negative, it's positive 0.800, which brings me to an important point. If this is negative and this is negative, when you do a reciprocal transform, the sign flips. So if the first two have been positive, then the inverse would be negative and vice versa. But if we look at the absolute values, which one is the strongest? 826 beats 800 and 694. So the best transform is the log y transform because it has the strongest r. So once we've done all that, that's fine. Let's do another example. This time we're going to do GDP versus life expectancy. Again, this is all genuine data. And so the first thing you do is put your numbers in the calculator. So again, keep a track of your lists. List 1 equals x, and the x is GDP. And list 2 is our y, and we got that as life expectancy. All right, and so we do the usual thing. Oh, of course, residuals into list 3. And there we go. So no transform. R equals 0.832. Just want to do a little digression here about this number here. So just to remind people that 4.3742 neg 4 is the calculator's way of writing 4.3742 times 10 to the neg 4. That means you've got to go 1, 2, 3, 4 spaces to move the decimal point. Put your zeros in there, so you can see that that actually equals 0.0004372. I just wanted to point that out to people that obviously 3 decimal places you get 0, whereas 3 significant figures is quite different. Scientific notation, look on my other videos about that, but I just wanted to show that these things pop up in your calculator, don't ignore them. Okay, back to the maths. So Here we've got our transform. We can see we've got frowny face, so you probably want to stretch in the y direction, that'd be y squared, or shrink in the x direction on your circular transformations. Obviously, we're looking at this top left area there, the transformations, and so we can do log of x or inverse x. Those are our three possible transformations. What the heck? Let's do all three. All right, see which one is the best. How do we know which one's the best? It's got the best R. All right, so we're going to do a scatter plot, this one versus list 3. There's our residuals. There's the clear frowny face. Let's do our first transform. Again, you click at the bottom of list 4, cal appears, and we've done that. This list 4 is, we're doing list 2 squared, so you can see that as actually y squared. So for our y squared transform, R equals list 1 versus list 4, and R equals 0.860. So we've got an improvement, not a huge improvement, but y squared is definitely the winner so far. All right, let's do another transform. This one's going to be list 5, and so we click to the bottom here, cal appears, and we're doing log of list 1, which is log of x, so that's log of x. And so log x transform, what does R equal? List 5 versus list 2. Make sure you're getting the right lists versus the right list. And so we get R equals 0.868. All right, so that's actually even better. So far our winner now is log of x. Let's do that final third transform. Clicking the bottom of list 6, cal appears here. We're doing inverse x, which is 1 on list 1. So list 6 equals 1 over x. So inverse x transform. R equals list 6 versus list 2. You can see why you need to keep this list going, because it's just all over the place otherwise. And we get an R of minus 0.482. So remember, whenever you do an inverse, you flip the sign, sort of thing. But which one had the best transform? Looks like log x was the winner. Why? Because it's got the best R.